Hi, my name is Jason Alvarado, and today I'm going to talk about Raycasting and Doom, the video game. In this video, we are going to talk about the transition from 2D games to 3D games. Specifically, we are going to talk about Raycasting and Doom, the 90s video game along with Wolfenstein 3D that brought the idea of using raycasting to recreate a 3D game without making a 3D game. First, we are going to talk about raycasting and its origins. Then I am going to give you some background to understand what was the situation for ID Software, the developers of Doom and Wolfenstein back in the 90s. And finally, we can get to know how raycasting worked in Doom. Okay, first of all, what is raycasting and where does it come from? Raycasting is a technique or approach to solve a problem related to representing solids or objects in a three-dimensional image. This technique got its origins in the 80s, and it was based in cellular array processors or CAP, and they consisted in an array of processors that managed to process and store subimages, and had window controllers to print the stored subimage in a certain area on the screen. This kind of technology was intended to be used for modeling solids in an interactive and efficient way, using different algorithms and implementing different techniques to make it more dynamical. Basically, the raycasting consists in generating a light beam that will travel through every pixel in the space until it hits the surface. This is also called volume raycasting, because the beam pierces through the surface to give information about the solid's volume. And what's the difference from ray tracing? Well, ray tracing consists in generating a light beam too, but the information we are going to get, or the information we are looking for, is the traveling of the light beam, its intersection with the surface, refraction, and its reflection and division in other light rays, while volume raycasting consists more of a light ray that travels through the solid to give information about its volume. Both raycasting and ray tracing use light rays, but ray tracing's purpose is to recreate a photorealistic scene where light and physics behave just like in the real world, while raycasting's purpose is more for location and volume. Soon we will see how raycasting was implemented in video games. Before Doom came out, ID Software was created in 1991, founded by some game developers, among them John Romero, Tom Hall, Adrian Carmack, and John Carmack. These people worked before on several other gaming projects, and they all worked for Softdisk. Tired of top-bottom video games, they wanted to create a shooting game in 3 dimensions. We can call these guys the father of first-person shooters, and also the first to introduce a 3D-like environment in video games. Sad fact, there was no way of generating a 3D environment in a video game, or at least, it wasn't possible with the processing power available for a console or a regular computer. So it was a challenge for them to solve this problem, but they managed to success in a very smart way. But what is a top-bottom game? Well, a top-bottom game is a 2-dimensional video game that's designed to be played from a specific perspective. Imagine you are watching the game from the ceiling, so you see your character from above. This kind of game is kind of a third-person perspective game that makes you feel like you were playing a board game because it feels totally flat. So, the thing was, we want a 3D video game, but we can only process a 2D video game. So they said, let's make a 2D video game look like a 3D video game. Sounds easy, but was it? How can you make something like that without actually processing a real 3D scenario? Well, these guys used a raycasting in a revolutionary and clever way. first implemented in Wolfenstein 3D, that actually wasn't 3D, it just looked like it. They created a top-bottom video game just like Bomberman, Alien Breed, Frogger, Chrono Trigger, and Contra, but instead of displaying on a screen a top-bottom video game, they used light rays that traveled from the main character vision forward until they hit a wall or a surface. This generated the images that were going to be printed on screen, instead of the top-bottom map that we all know. But let's get deeper in the functioning of these techniques for this game. Even though they were not processing a 3D scenario, casting rays in every direction required a lot of processing power, and not all the scenario was available for the user to watch at the same time in a single screen. So, was it necessary to process all those images that were not going to be used in that moment? To solve this, the team decided to only cast rays in a 60-degree width, and a ray for each pixel in that range. This meant that each ray would display a single column of pixels. By mathematical functions and trigonometry, the distance between the position of the player and the pixel where the ray landed could be calculated and get a value of depth of that precise column of pixels. That depth value was very important, because depending on that, the display of the column of pixels was going to look bigger or smaller. And why is that? In paintings and drawings, there is a technique called vanishing points, and it consists in drawing straight lines that converge into different points and making your drawing or painting converging into those points along the lines to give the sensation of within a 2D plane. As we can observe in real life, when we are near to something, it looks bigger, and things that are far away look smaller. So, if the depth value for a pixel column was high, that meant the pixel was very far, so that pixel column looked smaller. One problem with this was that depending on the design of the level, a single ray could hit several surfaces, and that implied a lot of use of processing resources. Also, things that were behind the wall could be seen. They got rid of both these problems by using algorithms of hidden surface that resulted in not processing the surface that were not going to be displayed for being hidden behind another surface. This way, raycasting made a 2D game look like a 3D with very little resources. But still, it wasn't enough for ID software. The game felt very unrealistic. Everything looked square, like every room was a box, with no high grounds, stairs, or irregularities. So they kept innovating, and that's where Doom makes its first appearance, using the same raycasting technique, but implementing new ideas to make the game feel more realistic, or at least as real as it could feel, because it's a game about a demonic invasion in one of planet Mars' moon. They decided to make a 2D top-bottom game again, just like in Wolfenstein, but instead of having every scenario and room displayed on the same level and height, they managed to segment each map in different rooms, and each room in different sectors. So, every ray displayed an image depending on which area the player was. And since there could be different sectors on the same room, this gave the opportunity to make things look higher or lower from where the player was. Even though things looked higher or lower, there was no y-axis for the player. It was still a top-bottom 2D game, but at least now it felt like you could be shooting enemies standing on a mountaintop, a window on a second floor, or down the stairs. The only thing was that since there was no y-axis movement, you could only move your aim in different x-axis direction. So, no matter if an enemy was standing on a second floor and you were in the first floor, you only needed to aim in the right x-axis direction and the shot would always hit. Even though the game had limitations for not being a true 3D game, the way the developers used the resources available at the time was very impressive, and we could say they made a 3D game for a 3D impossible to run device, and it worked. Several years later came the real 3D games, but of course with higher processing power units. But still, we can say that those 2.5-dimensional games, Wolfenstein and Doom, opened the world of possibilities and a new genre to the gaming industry. First-person shooting games like Valorant, Call of Duty, Counter-Strike, Borderlands, and a huge etc. And this was all by now. Thank you for watching and I hope you liked the video.